So this is Unit 2, Module 3, Lesson 5, Android Logo number 2. So today we are going to continue with logo and algorithms. Today we're going to look at adding in some parameters to our methods. So yesterday, or the other day, when you had to add in your directions to get it to draw the face, if you wanted it to go forward 40 blocks, or 40 pixels, I should say, you had to do forward, 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 forward. You got to do forward 4 times. It would be better if you could just tell it to move forward 40 blocks, or 40 spaces. So you want to add in something that allows you to control how far it can go. The turn, right now the turn is limited to just a right 90-degree turn. That's very limited. It'd be nice if we could choose an angle and a direction for it to turn, so we can be more creative in our designs. Right now, to go the other direction, we have to make 2 or 3 right turns to go 180 degrees. So that doesn't work real well for us. It's very difficult to work with. So we're going to add in some parameters into our code. There is another startup file in this lesson that has all of the blocks, all the parameters that we dealt with before, only this time they accept parameters now. They're not just forward, it's forward with some information. So let's see what that looks like. So you get your startup file, just like we did before. It's going to behave a little bit differently. This time, we're going to look at using the procedure and adding in the parameters. And as you recall, we click on the little blue square. It's going to give us this input box, and we're going to drag that into the inputs. So now our procedure can take a specific parameter. So instead of drawing a square that is a 10 by 10 and forcing that method to just be squares that are 10 by 10, it'd be nice if we could draw a very universal square that can be any size without having to worry about specifying the 10 by 10 square, or the 20 by 20 square, or the 50 by 50 square. We can make something that is just a 22 square. So in this case, we would want to choose the length of the side of the square. So again, we click on the little blue square. We change our variable name to L, for example. And when we call draw square, we're going to put in a length of 40. So that way I draw a 40 size. But how do we make that happen? How do we make that square draw so it has 40 pixels in length? Well, it turns out in this method, we now have the ability to use the forward command with parameters. The forward command now takes a certain number of pixels in its command. So we're going to go forward L number of pixels, and you get to that get L just by hovering the mouse over the L there, and it'll give you the option to get L. And then we're going to turn, and look, we can choose the angle at which we want to turn this time. So we're going to turn 90 degrees. And then we're going to go forward L, then turn 90 degrees. We're going to go forward L, turn 90 degrees. We're going to go forward L, and again, turn 90 degrees to get us back to the start. Notice that we are repeating code. We're repeating those 2 blocks of code over and over again. So this might be worthy of refactoring in some way. So maybe adding in a for loop here that just executes those 2 commands 4 times. That would definitely simplify our code. I don't know if it's worthy of a procedure, but definitely some type of looping structure would be helpful here. So by adding in that loop, we can then have it do the same 2 blocks 4 times. So we're going to put in our for each number from 1 to 4, and we're counting by ones. And we're going to do these 2 blocks. So now our draw square becomes much shorter, and we can draw a square that is 30 blocks by 30 blocks, and that becomes very nice to use. So let's take a look at this one. If I wanted to draw a triangle, well, we're going to do it 3 times because there's 3 sides. We're going to move forward a certain number of pixels to actually draw the side, but the question is, what angle do we turn? So I'm going to pause the video. I want you to think about that, and then we'll come back with the answer. So it makes sense to choose an angle of 60 degrees rather than any other angle because we want an equilateral triangle. And if you take 180 degrees, divide it by 3, that gives you 60. So we can draw a triangle. Oh, but wait. If I draw 60 degrees, if I only turn 60 degrees, that's going to give me the interior angle. It turns out, because of the direction you're turning, you actually want to turn so you get the exterior angle. Because you want to turn so you end up drawing the outside of the line. So what we really want to put in is 120 degrees, which is 180 minus 60. So when you're doing these shapes, you're going to have to remember that you don't want the interior angle. We want the exterior angle. Because if you think about it, we're moving around the outside of the shape, not the inside of the shape. So that's why we want to use the exterior angle, not the interior angle. So you have to remember that when you do your calculations. Wow, what if I wanted to do any polygon? Instead of just doing a square and doing a triangle, what if I wanted to change this in such a way that instead of being a triangle, I can make it so it would work for any polygon, where I tell it the number of sides, and I could pick how long I want each side to be. That'd be a very useful method to be able to draw any polygon whatsoever. So I'm going to pause the video, and I'll have you guys think about it, and then we'll come back and talk about the answer. There's a nice little geometry fact that the sum of the exterior angles is always 360 degrees. So if I want to figure out what the measure of each exterior angle of an equilateral triangle is, what I need to do is take 360 and divide it by 3. So 360 degrees divided by 3 gives me the 120. So if I want to go and create something that works for any polygon, what I have to do is two things. First, I have to change my loop so instead of just going from 1 to 3, that would be a triangle, I need to go from 1 to the number of sides I'm interested in. 5, 6, 7, 10, 1,000. And what I need to do for the angle for the turn is instead of putting in 120 degrees, I have to put in 360 divided by the number of sides. That'll give me a method that allows me to draw any polygon I want. So it looks something like this. I get the number of sides. I added in two parameters, one for length, one for sides. And then I have my little loop here that goes from 1 to the number of sides that I was interested in. I'm going to still go forward L, but then I'm going to take 360 divided by the number of sides, which is that geometry rule that says the sum of the external angles is always 360. So if I take the number of sides divided into 360, that should tell me each individual external angle. So then I can call this procedure now and say I want to draw a 40-length, 5-sided figure, or a pentagon that has length of 40. And then I could do some really interesting stuff. Imagine taking this pentagon now, drawing it, rotating your character 5 degrees, then drawing your pentagon again, rotating your character 5 degrees, then drawing your pentagon again. Continue that, let's say, till you get to 360 degrees, and you've rotated all the way around. Think about what that shape would look like. It would be a pentagon on top of a pentagon, rotated all the way around. Now we can start getting some very interesting designs, some iterative designs. Now, in video gaming, a lot of you play some really cool video games, and the backgrounds on them are really intense. There's a lot of actions going on there. There's a lot of video going on there. Nobody sat down and videotaped that background. Nobody sat down and said, okay, let's make a little movie sequence, an animation of the ocean in the new Mortal Kombat 10 video. There's one of the scenes takes place like in front of a ship or something, and there's this big ocean waves that move all through the scene and constantly going with lightning. It's really impressive to look at. Nobody sat down and recorded a video for that. And the reason I know they didn't record a video is because there's no glitch. So you can always tell when there's a recorded video loop because there's always a glitch where it jumps back to the original starting spot. And you can see it. And some are better than others, but your eye starts to pick up the pattern. And you start to see where that video glitch occurs, where you see the repeat. And it kind of takes away from the effect of the game. So what they learned was that you can add in some type of code that designs the background for you. An algorithm that will choose your background. Suppose instead of turning 5 degrees, we randomly chose a number to spin our pentagon around. Well, that would give us a unique background almost every time, at least 360 of them. 360 different backgrounds, because we could choose a random number between 0 and 360, and it would give us 360 different interesting backgrounds that we could look at. And if we add in decimals, we get an infinite number of interesting backgrounds that we could look at. So we now have, from a very short piece of code, an infinite iteration of backgrounds. Well, they do the same type of things in modern video gaming. They take algorithms that are very short and they add in a small piece of randomness, or they're using some type of fractal design that is an infinite recursive, and I'm throwing some vocabulary words out here, infinite recursive algorithm that goes through and creates a background that always looks unique, that you've never seen before. Anybody play Minecraft before? It starts with a seed and randomly generates a background. So every world that starts with a different seed is going to be different. So you can always explore it in a new and interesting way. So there's always something new for you to look at. Nobody sat and designed that background from scratch. You can, right? You can choose some certain things in Minecraft to choose what the background is going to be. You could individually place all the blocks of all the mountains and all the trees, but nobody does that. There's an algorithm that does that automatically, and it generates it. That's why it takes some time to actually generate it. It's going through the algorithm and designing that. So that's what we're talking about here, is creating algorithms to design backgrounds. So there's a series of exercises that I want you to work on that's going to take you through that process of iterative design, building that polygon method, and then combining it with other things to get very interesting backgrounds that would take you forever to try to draw by hand, just using the logo controls. Forward, backward. We don't even have backward. Forward and turn, pen up, pen down. It would take you forever. You saw how long it took you to draw that happy face. When you look at some of the designs you're going to be able to do iteratively, you're going to get much better designs using algorithms than you could ever do by hand. So take a look, go into Blackboard, and in there, make sure this is clear to everybody. There's the notes from today, but then there's also this startup file. You have to download this startup file and add this to App Inventor. It's different than the one we did in Logo 1 because it has all the parameters built in. And then here's what you need to do. Here's the exercises that I want you to go through. And you can see all the different types of things that I want you to do. I just want to kind of scroll through this a little bit. And at the end, they start doing designs that look like this. So you can end up getting very, very interesting backgrounds and pictures all through iterative design. And they're going to ask you to create your own unique design at the very end. So go ahead, log in, get started on that, and we'll catch you on the next lesson.